Okay, so let's try and carry on with Zoom working. And yes, good point. I see good comments in the chat. All right, so here we go. So you can send a head request instead of a get, and that will load just the header, but it won't load the body like the HTML and the images and such. Options shows the allowed verbs. Put uploads to the server and is not used very often. And so a URL looks like this. You have a protocol first, usually HTTP or HTTPS. Then the host name is the name of the specific computer on the network. And that will also include the domain name in this print, then colon and port if it's on a port other than 80 or 443. And then you might have a folder name and a file name. And then you'll have the parameters here after a question mark, the question mark being the special character that delimitates the parameters. What's the difference between post and put? It's a very good question. Post sends just a few lines of text to data, like a username and password. Put can send up a file to be stored on the server. They both send data to the server, but post is just sending it to a service that's going to use that data for something like logging in, and put actually puts an object on the server. It's like an FTP upload, which is something you don't normally do with HTTP. Good. And REST is a way of expressing a URL. This is one of the many confusing things about the internet. There are many ways to refer to objects on a web page, and they're often pretty strange. So if this is a normal web request, you'd go to this thing called waapp.com, then you go to the search page, then you have a question mark and some parameters, make equals Ford, model equals Pinto. But if you wanted to, you can use representational state transfer, and then you just put the parameters right here as if they were folder names. I don't know why people do this, but they do. And so someone says you post data like images. Oh yeah, unfortunately, you are correct. You can post data and it will then be sent as a block of base64 or something. You're right, but it is sent to a server service at the top, which reads it as a parameter and then writes a file from it, which I suppose the same is true of put. But now that you mention it, I guess in principle, you could use put to do the same thing post does, but in practice, it's not done. Ah, good. Someone has a better answer. Put is idempotent. Ah. Oh, well, that's very interesting. Thank you, She-Level. And by the way, this is absolutely the right thing to do. If you know something I don't, bring it up. He says, put, if you call it multiple times, it will not repeat the effect, whereas post totally will. That's interesting. Sounds like put is pretty desirable, but I've never seen anybody use put. Anyway, and yeah, REST is used for APIs. They do like to do this, and I don't know why. Instead of having it in this form where you can tell the parameters from the folders, they mix them together so there's no way to tell. REST is not a programming language. It's just a way of formatting URLs. This way, where parameters turn into something looking like folders. All right. Well, let's try a Kahoot. Yeah, Rust is a programming language, absolutely. And we'll be doing a little bit of Rust in this class. Let me see if I can get my Kahoots. Here we go. Looks like this will work. There. Oh, that's not right. 129S. There. All right. All right. All right. Looks like we'll be okay. Oh, good. I see people making it in. Good. All right. And the fact that this is working makes me think that it definitely there's a problem at Twitch. That happened about 6 months ago. Twitch had some kind of server problem. I think it was due to an Amazon outage last time it happened. Good. Good. I see people telling other students how to get to the Kahoot. I appreciate that. I'll give it another few seconds to see if any more people are coming. Ah, yes, good. All right, I think that's it. All right, so what part of the request is get? That's the verb, I think also called method. All right. All right, what method requires user confirmation when clicking back? That's post, good. All right, so what parameters are stored in bookmarks? All right, the query string. And which of these is RESTful? All right, and I should just mention, this is the normal query string layout. This is XML, and this is JSON. They're all used on the web, all different ways of conveying the same information. But this is the RESTful one, which is the one I complain about a lot because you don't get the names of the parameters. But that is the one people use. It's one of the several techniques people use pretty often. So, Clayton. All right. I know who that is. I can look it up. And Jeff, good. Norma, good. All right. So let's just do another section here, and then I shall demonstrate some projects. I guess we're all right with this technique. Okay, so the headers in your HTTP request, there's a bunch of them. A connection tells it whether you're going to send multiple requests after the same TCP handshake. You can send up to 100 requests per TCP handshake to Apache if you allow that. You can encode it, like you can use zip to zip the content to make it smaller, to transmit it faster. You need to know the length of the body, the type of document contained, the transfer encoding. These are all parameters to tell the server at the other end what you've got. Accept tells the server what kind of content the client is willing to accept as a reply. And encoding, you can send authorizations And cookies, which are the general purpose parameter. They can have any parameter you want, which will mean anything you like to your application. This is the host name, the domain name, the server name, domain name, and top-level domain, specifying what computer you're trying to talk to. And if modified since is a clue about whether it'd be okay to use cached resources like images. And there's another one called if none match, which again determines whether you can use a cached copy. And there's origin, which has to do with AJAX requests. And cross-domain requests, which we're going to talk about a lot later as possibly a security problem. And the referrer I mentioned before, spelled wrong, it should have 2 R's. That's the URL from which the current request originated, but it is not verified at any point and could be falsified. And the user agent specifies what kind of browser you're using. All of these are not verified in any way and can be falsified with a tool like Burp. And so the response has a bunch of headers. Access control has to do with AJAX. We'll talk more about. Here's more caching directives and entity tags having to do with caching. When the content should expire if you cache it. You can use a location in redirection. This is if you get a status code 300, it will redirect you to another page on the same server or a different server. And this is actually an unfortunate thing people do. A lot of people take an HTTP request and they redirect to HTTPS. Now, 10 years ago, this made some sense because people had bookmarks that were HTTP only. But the problem is that means it could be intercepted while it's not encrypted and modified. So a lot of people still do it that way, but it's not a good use of a redirect. Pragma is more information to the browser. This is information about the server. This is how you set cookies. And once you set a cookie, every future request you make to the same domain will send that cookie with every request. So it's used to tag you, usually recording who you are because you've logged in. And these other ones we'll talk about later. All right. So I say cookies are the main thing. You'll set a cookie like this, tracking equals this. And now every time you send a request to the same server, you will add that to the header so the server can see who you are. HSTS is a security feature intended to address, yes, that's right. Not HCST, but HSTS, I think. Yeah, you're right. Good. All right, so this is how you set it. Now, when you set a cookie, you can tell it when the cookie will expire and what domain it's valid for. This is a fundamental browser security issue called the same origin policy. So if you set a cookie on Yahoo, that cookie would never be sent to Google. This is a fundamental security feature of browsers. The problem is there are a ton of ways to confuse your browser, so it thinks you're at Yahoo when you're not really at Yahoo. So the same origin policy is often defeated, but it is a fundamental feature for browser security, such as it is. You can specify the path for which the cookie is valid, so it will only send the cookie when sent to that certain domain and certain paths. You can tell it to only submit the cookie over HTTPS with the secure flag, and you can tell it to only send it over HTTP with HTTP only, and then it will never send it from JavaScript. And this is considered a very good security measure because cross-site scripting involves adding JavaScript to a page that runs in someone else's browser, and the main thing you do with it is steal cookies. If those cookies had been set to HTTP only, that attack would not work. If you don't accept :80, request to the example.com would not be received by the server. Well, that sounds right, yes. All right, so the status 200 is the most common one, meaning the request was successful. And when things are wrong, you get 300, 400s, or 500s. 300 is just redirects, meaning I understood your request, but this page has moved and loads some other thing. 400 means it can't find it usually, and 500 means some script on the server crashed. When you're trying to hack into servers by injecting code, 500 often means it works. You managed to cause the server process to misunderstand the request. So 301 and 302 are things that have moved to other locations. 400 is a bad request. 401 is unauthorized, forbidden, and 404, the most common one, not found. Yeah, and 500, that's right. That's a fair statement. 400 means the client made a mistake. 500 means the server made a mistake. That's a fair statement. So 500 is an internal error, like you sent up some parameters which the PHP script could not understand. And a lot of people make jokes about this, 204 no content, 401 unauthorized, 408, people have a lot of fun with these numerical codes. So HTTPS is HTTP over secure sockets layer, although SSL is now obsolete and no longer used. Now we all use TLS, which is the upgrade. And this adds encryption and authentication to HTTP. So first it gets a certificate from the server to prove who you're talking to, and then it encrypts all your data. So it makes sure that nobody else can see it except the server you really intended to talk to. Now you can have proxies, like I do. You may remember when I demonstrated going to my page, it didn't load from samsclass.info, it loaded from Cloudflare. I use Cloudflare, which is a reverse proxy service. So when you try to load my page, you are not sending traffic directly to my server. It's going to a proxy server, which hands the content over to you. This makes my page respond faster, and it uses less bandwidth, and it protects me from attacks. So a lot of people use reverse proxies on the server or proxies on the client, like Burp, which intercept traffic going out from my browser and let me modify it. All right, so as I mentioned, HTTPS is valuable to prevent man-in-the-middle attacks. If you go to a wireless network in a coffee house, you can redirect traffic so it goes through your machine and put yourself in the middle between the client and the server. And if in HTTP, that is undetectable and unstoppable, and I could intercept traffic and read confidential traffic and change it. But with HTTPS, I can't do it because I cannot create an authentic certificate that will verify that I am, say, Google. And I'm trying to put myself between you and Google. So what I'd have to do is put a fake certificate, which will cause a warning box to pop up in your browser saying this certificate is no good. Or I will have to do the very difficult task of somehow getting a real certificate from a trusted certificate authority, which is not a real Google certificate. And that is something only the more advanced attackers can do, or the nation states, or corporations who can bribe certificate authorities into giving them root certificates for purposes of intercepting traffic. And law enforcement agencies can do that too. It is kind of it used to be an open secret. I think now everybody pretty much knows, just like the cops can man in the middle your cell phone traffic with those stingrays. They drive around in trucks and intercept your cell phones. They can also intercept your HTTPS by getting certificates from certificate authorities. The whole security model of the internet relies on the certificate authorities not selling their certificates, but most of them actually do it, and they've been caught doing it. And a lot of people get pretty mad about this, but no solution has been found yet. But low-level attackers can't get those certificates, and so HTTPS protects you from them. All right. So there's also HTTP authentication. The original one was basic authentication, which just put your username and password in base64 encoding, which is not encryption. It just obfuscates it and sent it that way. Microsoft had one for NTLM, which I've never seen used, maybe used only on local Windows networks. There was one using MD5 hashing, which is also not very safe. All of these are weak cryptographically. So if used over HTTP, all these tend to leak your password. But if you use them over HTTPS, then they're okay, because the HTTPS has strong cryptography, which encrypts this stuff, which is not very, very encrypted, and that amounts to making it safe enough to use. All right. So let's look at the next Kahoot. And that's as far as we're going to go through these slides today, which is 129S3B. There. While that's happening, I'm going to put a note in the Twitch for people who came in late. Good. All right, looks like we got everybody that's coming. All right, so what header tells the server what web page you're coming from? That's the referrer. Good. All right. So where can a server specify that the cookie must always be encrypted? That's it. When you set the cookie, you can specify secure, and then it will only be sent with encryption. All right, what status code means the page was not found? Yep, that's it. 404, very famous. All right. So what transport protocol is HTTPS using? All right, TLS. There are various versions of TLS, but we're all using one or the other of them. All right. Look up who Woot is. And Alchemy, I know can look up who that is. Eileen. That's probably only one Eileen. All right, good. So, all right, I'm going to stop this recording and make a separate recording.